right, well, we're going to pick up, still practicing. For those of you who are like, I still need more practice with the factoring, we're still factoring today. But we're going to take it that one step further and actually solve for x. All right. I do have for you, I don't know if it will help or not, but I have it just in case it might help you. It's a bit of a flow chart for factoring. So it's got kind of your breakdown. First thing, obviously, is always your greatest common factor. And then it kind of branches off after that, depending on how many terms you have. So obviously, put like terms together first. Then this may help you kind of determine where to go. Okay, so first thing, factor, GCF. And then, is there 2 terms, 3 terms, or 4 terms? 3 terms is just your straightforward factoring. It's what we've been doing, since the beginning of the school year. 2 terms, you can either go one of 2 ways. It can go difference of squares. Hopefully it recognized difference means minus. Squares, they both have to be perfect squares. Or if it's 2 terms, it could be your sum or difference of cubes, meaning both of them are together with a perfect cube. And I kind of break it down for you, taking the cubed roots, square multiply square, how all that goes, the word soap, and all of that. So you have it kind of here in front of you. And then 4 terms, group first 2, group last 2, pull out GCFs, common parenthesis, and what's kind of left over. That's how that one factors. So notice that is a colored piece of paper I gave you. Do you remember what that means? Anything on a colored paper? Did we talk about that in here? Might have been my other class. Anything I give you with a colored piece of paper, you can use on your final exam. So don't write all over it, or I'm going to not let you. Okay? So if I give something to you on colored paper, you can use that on your exam. Is that on a colored piece of paper? Yeah. So you can use that then on your exam. Yeah. So you get happy when I give you colored paper, okay? You get to use that stuff. Look at you guys now like, wait, what else is colored in here, right? Going through all your stuff. All right. So there you go, in case that helps you out. All right. So solve by factoring. We've solved by factoring already, but now we're just going to keep doing this with our different types, which kind of changes things a little bit, but it takes all the stuff we learned in Chapter 4 and puts it all into this. So put each equation in standard form, meaning set it equal to 0. Factor completely based on if it's quadratic, quartic, factor by grouping, sum or difference of cubes. You have to be able to look at it and know. Hopefully that green paper I just gave you might help you a little bit, kind of have some direction. Then you'll set each factor equal to, 0, thank you, and solve. Have we done this before? Yeah, we have. Most of you, I think, at this point have gotten to the point where you can see it just like, oh yeah, x equals 3, right? Like you can see it, you know what it is, don't have to show your work. You're going to have to show your work with some of these again today. Remember, the blank of the polynomial is equal to the number of solutions or zeros. How do you know how many answers it's going to have? The exponent, which is called the degree. So if it's a 5th degree, you better have 5 answers written down. This is where it's real important to notice that, because it's easy to forget some of your answers. Or baby brother gets lost somewhere through your problem. Make sure you don't lose him. He's going to give you answers you need. If an equation cannot factor completely to linear factors, so meaning back down to like x plus 5, right? So it's really easy to solve. Then you're going to have to use either the quadratic formula. That was from Chapter 4. Or finding square root method when necessary. Oh yeah, Chapter 4 comes back again. Solutions or zeros may be blank or blank. What do you think? I agree. Not what I was looking for, though. Real or imaginary? It can be real or imaginary. So remember, if you take the square root of a negative number, that's where that I comes back out. All right, so let's start with some quadratic ones. So solve the equation by factoring. So now we have that equal sign that comes into play. And then remember on Friday we talked about, like, well, can't I just move everything? I'm like, move it where? Right? There wasn't an equal sign. Now we have that. Go ahead. So we'll go ahead and set it equal to 0. So 2x to the 4th. I'm going to move it over as minus 5x cubed. minus 12x squared equals 0. First thing I do for factoring is GCF, which in this case is 2x squared. Just x squared, yeah, that 5 there. All right, so take out the x squared. So we have 2x squared minus 5x minus 12. All right. Once you take out the GCF, then stop and ask yourself, what type of factoring is it? Is it quadratic, cubic, quartic, or grouping? It's quadratic. It's 2x squared. So that's just our straightforward normal factoring. So I'll set up my parentheses. Last one's negative. I know my signs are plus, minus. Good. Options for A. 1 and 2. So 1x and 2x. Options for C. Ooh, we got some options here. I like them in order, sorry. All right, so you want to go 1 and 12, 2 and 6, 3 and 4. I know right now one of them doesn't work. Without doing any math, I know one doesn't work. Without doing any math, one doesn't work. Okay, I agree 1 and 12 doesn't work. But why? What's the other one I was looking at? Because I have a 2 here. 2 and 6. No matter which one I'd put here would make a GCF inside of here, and there's not one here. So I know that's gone. You guys are right, just by being smart, you can tell if 1 and 12 doesn't work, right? Well, that should make it pretty easy, because I know what number cannot go here. 4 can't go here, so this would have to be the 4, this is the 3. Are my signs okay, or are they backwards? They're backwards, because that would give me 8 minus 3, which is not make negative 5. So fix your signs. All right, and then we'd set each factor equal to 0. So is this one that I can do in my head probably for most of you? Yeah. So what does baby brother give me? Good, 2 zeros. This one gives me, and this one? Good, negative 3 over 2. Again, if you're somebody who is not confident and wants to write those out, write them out, okay? Not going to fault you for that. All right, do we know that there should be 4 answers before we started? Yeah, the original problem was x to the 4th, so yeah, I should have 4 answers. Are we okay here? I'm going to jump through some of the quadratic ones because we know quadratic. All right, let's look at 4. We'll jump to 4. I'm going to bypass some of these. So number 4, what should we do first? Set equal to 0. Good. We're factoring, set them equal to 0. So 9x to the 4th minus 64x squared. Okay. GCF? Just x squared. So 9x squared minus 64 equals 0. All right. 2 terms. Look at your green paper. 2 terms is either going to be difference of squares or your cubes. Do you have squares or cubes on there? It's x squared. That should make it an easy one, right? So I know it's not the SOAP pattern. That's just my favorite. How does that factor? Good. I like those. They're fast. They're easy. And then is this one I can solve by doing it in my head? Yeah. So what does x equal? Good. And my original problem was x to the 4th, and I have 4 answers. Could you be lazy and write plus or minus 8/3? Yes, you can. If you're listing answers, you bet. Can you factor and write 3x plus or minus 8? No. Not in factoring, but when you list answers, yes, you can. All right. Jumping to the next type, where things change a little bit. So quartic. So number 6, first thing, always set equal to 0. So let's move the 15. Okay, so once we move that, is there a GCF? No. Now I recognize this is quartic because it's x to the 4th. Okay. Do I factor quartics much different than quadratics? No, not really. Okay, so let's set up our parentheses. Last one's negative, so my signs are plus, minus. Options for A. Good. The only thing I have to make sure I remember is that's x squared. And then for C, 3 and 5, which one's negative? The 3. Okay, good. Now this is where things change just a little bit, but it's stuff you should know how to do. We said each factor equal to 0 and solve. Well, how do you solve this? Do what? I gotta do something before I do that. I gotta move the 5. Remember square root method? You have to get the square term by itself. So this is x squared equals negative 5. Then I can take the square root of both sides. So what does x equal? Plus or minus I square root of 5. About 3 of you all put together got the right answer. Yeah, I can't take the square root of 5. It's not perfect, so it stays under. But the negative comes out as an I, and if I take the square root, my answer is plus minus. If I look at a graph, will I see this answer on my graph? No. Imaginary does not cross the x-axis, so I won't see that one. Here, move the 3 to the other side. So x squared equals 3. Take the square root. So x equals plus or minus square root of 3. Now, I'm supposed to have 4 answers. Do you have 4 answers? Yes. Plus or minus, right? Those are 4 different answers there. Will you see plus or minus radical 3 on a graph? Yes. It's not a pretty place where it crosses, but it does. It's like 1 point something. So yeah, that will cross here, but this one would not because it's imaginary. All right, how about number 7? What do you do first? Bless you. That's a really long, drawn-out sneeze. What do you do first on number 7? Good. Move the 13x squared. Where should it go? There you go. All right. Do you have a GCF? No, nothing comes out. All right. This is quartic, which means I'm just going to factor that just like I do my quadratics. Last one's positive. Are they both plus or both minus? Both minus. Good. Options for A. Good. 1x squared and 3x squared. Options for C, 1 and 4 or 2 and 2? Good. It's going to be 4 and 1 because that'll give me the 12 and 1, which makes it 13. All right? Now, some teachers would make you look at that and go, oh, look, there's x squared minus 4. That's a difference of squares. I can factor further. Okay? Some would make you factor further. Do I have to if I'm solving? Can I solve that? Yeah, technically I can solve this from here. All right, so once it's factored, we set each factor equal to 0. And we solve. What's up, ma'am? Oh, you didn't go to work today. All right, so solving the first one, we have to add the 4 to the other side. So x squared equals 4. Take the square root. Plus or minus 2. If you had factored, that would have factored to x plus 2, x minus 2. So there's your plus and minus 2. Here, what do I have to do? Good, move the 1. So 3x squared equals positive 1. Can I take the square root now? Divide by 3 first. Some of you messed up on that on your test. 1/3. How do you take the square root of a fraction? Some of you still don't know. Top and bottom. Don't be lazy and put one big old radical over there. That's where you get yourself in trouble. What's the square root of 1? 1. Square root of 3? Can't. Is that pretty? No. Multiply top and bottom by radical 3. Radical 3 over 3. If you want the one there, you can. If you don't have to. And then don't forget your plus minus sign. This was quartic. I should have had 4 answers. So I get plus or minus here and another plus or minus on that one. So I do have 4. But yeah, that whole square root method, rationalize the denominator, don't forget your plus minus, don't forget your i's, separate negatives, all of that stuff, it comes back. Math is useful, right? You guys would probably disagree, but you know. All right. I like that problem though, because it like brings everything that we've learned so far and puts it all in one problem. It's kind of nice. All right. Number 8, on your own. All right, let's talk through 8. So first thing, make sure you are setting it equal to 0. A couple people, that was not your first thing that you did. All right, was there a GCF in this one? No. Okay, so it is quartic, which we factor like quadratics. We'll set up our parentheses. Last one's negative, so they're plus minus. Should go 1 and 6 or 2 and 3? 1 and 6. So 1x squared and 6x squared. And then we have 1 and 2. So that should be 2 and 1. Okay, so mine's set up correct. All right, then set each factor equal to 0. And then solve. So we have to subtract 2. So x squared equals negative 2. Square root. So we should have gotten plus or minus I radical 2. Will that show on a graph? Nope. Here we have to add the 1. Then we divide by 6. X squared equals 1/6. Take the square root of both sides, or top and bottom. So that's going to give me a 1. I can't leave that on the bottom. So you're going to end up with plus or minus radical 6 over 6. So plus or minus I radical 2 and plus or minus radical 6 over 6. Questions so far? Should the solving really be new? No, we should know how to do that. It's just a matter of kind of putting all of this together. All right, number 9. It's already set equal to 0. What type of factoring is that like? It's 2 terms. Is that the cube stuff where I have to use SOAP, or is that more like difference of squares? It's like difference of squares. Yeah, it's not a cubed, right? It's not x cubed. So let's set it up like we would difference of squares. So 1's plus, 1's minus. X to the 4th will become x squared. And 16 will become 4. Technically, I could keep factoring, but I'm just going to go ahead and solve once I get to that point. Set each one equal to 0. And solve. So subtract the 4. Square root. Maybe. There we go. What's the square root of negative 4? Just 2i? And that killed so many of you on your last test. And then move the 4 to the other side. Square root. Square root of 4? There we go. How many answers should I have? I should have 4 plus or minus, plus or minus. So I do have my 4 answers. Number 10, on your own. All right, guys, let's talk through this, see how we did. So set it equal to 0 first. So 81x to the 4th. What happens when I move the 13 over? 121. A couple of you didn't recognize those were like terms, so make sure you put like terms together. So I have 2 terms. Is that the SOAP, the cube pattern, or is it just like a difference of squares? It's like a difference of squares. Okay, it's important that we recognize that. All right, so I know 1's plus, 1's minus. Square root of 81x to the 4th, 9x squared. And square root of 121. So there it is factored. Okay, from there we set each one equal to 0. And solve. So let's subtract 11. Then we divide by 9. x squared equals negative 11 ninths. Then we take the square root, top and bottom. So I can pull the I out, so I radical 11, and the square root of 9 is 3. Some of you who try to rationalize first ended up with a really ugly thing going on there. Okay, I do not have to rationalize. It does not have a radical in the bottom. All right, over here, we will add 11, divide by 9, take the square root, top and bottom. So I get plus or minus radical 11 over 3. Is that the same answer twice? No, it is not. One's imaginary, one's not. If I would graph this, this one does not show up on my graph. This one, while I would probably never guess that that's what the fraction looks like, I could at least find the decimal answer for that on my graph. Okay. How are we feeling? You okay for me to keep going? Good. I'm not doing it. Moving on. Overachiever. All right, let's move on to our factor by grouping. Woohoo! 4 terms. So again, first thing, set it equal to 0. So I'm going to move that 3 over. Right? These are easy to recognize. Once you put like terms together, and there aren't any here, I still have 4 terms. So we are going to group the first 2 and the last 2. And I'm done, right? I can stop there? Yeah, please don't. All right. GCF in the first set? X squared. What do I have left if I take out an x squared? X plus 1. Some of you like to lose that plus 1 on there. Make sure that's there. GCF in the second set? Negative 3. What do I have left? X plus 1. Remember that whole dividing by that negative. You got 2 negatives, going to make a positive. All right, don't stop here. What's your common factor? X plus 1. So remember, it's like I'm factoring that out. When I factor that out, what do we have left? X squared minus 3. That is factored. People always try to stop here. That is not factored yet. This is factored. I do not have 2 x plus 1s. That's like my common factor. I pulled it out in front. I'm factoring it out. Okay, then we set each factor equal to 0. And solve. So x equals negative 1. Finally something easy, right? And then over here, add 3. Take the square root of both sides. So x equals plus or minus radical 3. How many answers am I supposed to have? 3. How many do I have? 3. There's 1 there, 2, 3, plus minus. All right, do 13. All right, let's see how we did. So first thing, let's set it equal to 0. So 4x cubed plus 4x squared minus x minus 1. 4 terms, so we're going to group the first 2, group the last 2. GCF in the first set. Good. What do we have left? GCF in the second set. Negative 1. X plus 1. Common factor that we can factor out is x plus 1. The leftovers is 4x squared minus 1. Okay, so there it is factored. Then we set each factor equal to 0. And solve. So we x equals negative 1. Here we'll have to add the 1. Then we divide by 4. So x squared is 1/4. Square root, top and bottom. What's the square root of 1? Good. You should get plus or minus 1/2, and then a negative 1. So we have our 3 answers. Yay? Doing all right? No, thanks for asking. You know me, I do hop, skip, and jump through things, right? Let's look at 15. We'll skip 14. Let's look at 15, though. I know things show up here, so I want to make sure we talk about it. So 15 is already set equal to 0. No. So we have 4 terms. So I'm going to go ahead and do grouping. So first two, last two. GCF is, all right, time out for a minute. Hamid said, wait a minute, there's a 2x GCF in the entire thing. I agree with him, there is. Now, did I take out GCFs first on grouping on Friday? I didn't. You can, but this is like the one time I don't, because what's going to happen is if you pull out a GCF first on grouping, then when you go to put things in parentheses, that GCF, baby brother's in the way, and he gets so confusing. This is the one time I don't take it out first. I'll take it out later, okay? So one time I'm not going to yell at you to take out GCF, but I'm glad that you noticed it. GCF in the first set, good, 6x cubed. So then we're left with x plus 2. GCF in the second set, 2x. So we're left with x plus 2. Common factor is x plus 2. Leftover stuff, 6x cubed plus 2x. All right, let's just say you don't even notice it at that point. We'll just keep going. Because most of you, when you do this on your own, that's where you're going to end up, and you won't even notice it. So then you would set each factor equal to 0. Now I'm looking at this going, what the heck is that, right? Is there GCF sitting here? Take out the 2x that's sitting there as a GCF. Now is a good time to take it out where it doesn't confuse you like crazy. Okay, so now I can continue solving. So what's one of the answers from that set? Okay, this one gives me -2. What about here with what I just did? Baby brother? Gives me a 0. And then here, I'm going to have to set that equal to 0 and solve. Thank you. 3x squared equals -1. Divide by 3. So x squared equals -1/3. Look at that. Everything I've taught you guys just keeps on coming. Isn't that exciting? I love it. All right, so x equals, what happens, what's the square root of -1? I, there it is. 1i, or just I, over radical 3, which we can't leave that. So we multiply top and bottom. So x equals I radical 3 over 3 and plus minus. Holy smokes, if you ever were lost in chapter 4, you are lost now. How many answers should this problem have? 4. Do I have 4? Yeah, I have 1, 2, 3, 4. How important is it to go back and do that mental check of how many answers you should have? Extremely important. It's really easy to lose. You know, let's say you got going over here, you totally forgot about this little simple answer here. It's easy to happen, you forget it. Or, baby brother, we forget about him a lot. Okay, so go back, do that mental check. Do I have the right number of answers? Bless you. How are we feeling about grouping? That one's a little crazy, but. All right. All right, so number 16. Hopefully you're starting to recognize that it's the cubes, right? 2 terms. Is it either the difference of squares or is it the SOAP pattern? You have an x cubed. It's a SOAP pattern, okay? It should be obvious. All right, so is there a GCF before we start, though? No. Okay, so let's set up our parentheses. Remember, this is where we use SOAP. This is Neil's favorite, right, Neil? He likes this one. Neil is like, he's like, get to the SOAP ones. I want to shine. Like, this is the ones he likes. All right, so filling in your signs. Same, so it's a plus. Opposite, and then always positive. How do we get the first 2 numbers? Cubed root. Cubed root. So what is the cubed root of x cubed? Cubed root of 27 is 3. Do I care about the original problem any longer? Nope. All right, and then this is square multiply square. What is x squared? Multiply, what's x times 3? And square, what's 3 squared? Ooh, should we try to factor this further? Why not? Why am I not allowed to? You guys actually listen to me now? Wow. It won't. Yeah, sometimes it's probably accurate. It never, ever will. You're right. It never will. You can try all day, but it won't, I promise. All right, so let's go ahead and solve. What's x equal here? So this equals -3. If that won't factor any further, how do I solve that? You had 3 methods for solving last chapter, right? You had factoring, which it won't. Square root method, it's got to be x. So what do I have to use? Quadratic formula. No, I'm kidding. We'll just stare at it and the answer will just come to us. It's a jar of almonds. That's the answer. It's a great answer. You're going to have to use the quadratic formula. You guys act like it's like the super huge formula. Yes, maybe I need to play it again. The really obnoxious one. All right, -b is 3 plus or minus square root b squared minus 4 times a times c all over 2 times a. Quadratic formula. Remember, we clean up under the radical next. That is -27. Thank you. Then we actually try to factor tree. So we get 3 plus or minus 3i radical 3. You had the I, you remember that. But I got a pair of 3's that come out and a single left in. And that's over 2. And then the last step is do all 3 numbers divide? No, all 3 do not. So that would be done. So is solving cubes terrible? Oh my gosh, I had to use the quadratic formula. It's so terrible. Oh, you have no idea. You have no idea. This is child's play compared to some of the math that I've done in my life. Oh my gosh, yeah. We did a problem that took us like 6 weeks to solve it. The same problem. I'm not kidding. Yeah, like every day, 3-hour class for like 6 weeks. I still have the notebook, yeah. I have all my stuff from college. If I find it, yeah. It's up in the attic somewhere. Yes. I don't know. Let's find out. Let's try some more. No. All right. 17. Let me keep going, and you will like me a whole lot once we do a few more, okay? I promise you. You will like me. Just hang with me. All right. 17. Is there a GCF there? Two. They're both even. All right, so let's take out a 2. That's grouping. Yeah, grouping down the 4-term ones. So 64x cubed minus 729. Mental math at its finest right there. Not bad for a Monday morning. Oh, afternoon. Yeah, I did that in my head. It's really not bad. How many times does 2 go into 14? 7. And then it goes into 58. 58 divided by 2 is 29. That's long division in my head. That's all I'm doing. Yeah, that's just long division in my head. That's all I was doing. Just like here, 2 goes into 12 6 times, and 2 goes into 8 4 times. Yeah, just doing long division in my head. That's all I'm doing. All right. Oh, that's really sad. You guys, there's so much cool things with math that like you guys missed like in the younger years, which is really sad. All right, so going further, so this is our SOAP pattern, right? So we have two terms and it's the cube thing. All right, so same math 4. The button under the green one? Under a green? See the green button? Do you see the green button? There you go, math, and then I think it's 4. All right, what's the cubed root of 64x cubed? It is 4x. Cubed root of 729 is 9. And then square, multiply, square. What is 4x squared? 16x squared. Multiply 4x times 9. Do I change it to the negative? No, I put my signs in first so I don't have to worry about it. So that gives me 36x. I'm glad you said it, though, because people always try. And then 9 squared is 81. Yeah, we do signs first with SOAP. That way I don't even have to worry about what signs are. Already in, they're done first. Why? It takes too long. Does baby brother give me an answer? No. Is there an X with him? There's no X, right? X marks the spot. There isn't one, so he doesn't give me an answer. What about here? That would be a positive 9/4. Should I factor that? You can try. It won't work, I promise. It won't work. I have to use the quadratic formula. So negative b is negative 36 plus or minus square root b squared. Because you should know how to do this. 4 times 16 times 81, oh my, all over 2 times 16. That's pretty. 6 squared. No, I don't know that in my head. I can tell you the final answer right now in my head, but I can't tell you what that radical is. Nope, it's the first time I taught it today. Oh. Do I have the answer key on me? Nope, haven't. I'm serious. I will tell you how. That's why I told Chris he's going to like me if he lets me finish a couple more problems. Isn't that pretty? Answer is not 0. All right, what's your next step? I know you're not going to like it, but what's your next step? No. Thank you, whoever just said that. Factor tree. Dividing all of them is the last thing I do. I'm going to do this off to the side just because it's really big. Get out now, office. That is not okay. Office is the other way, Quinn. You can, but wow, that was uncalled for. I mean, you may not like the quadratic formula and factor trees, but that was a bit much. Okay. All right. Here we go. So we are doing the factor tree on that lovely number. So just to make you all angry, I'm going to go 2 and 1944. 1944. I'm going to divide by 2 again because I think that's fun. 2 and 972. Divide by 2 again. 2 and 486. Oh, you're just going to wait? That hurts. Oh. All right, so that's going to be 2 and 243. That's going to be 3 and 81, which is 9 and 9, which is 3. See, Chris wanted me to give you your homework already. I'm thinking he wanted to let me finish. Don't you think? All right, so we got a pair of twos, another pair of twos. I'm just cleaning up the radical. Yep. Yep, but not everyone will understand my simpler way, so they'll still do this because people are painful. Another one. So b4 times 9, which is 36 radical 3. So negative 36 plus or minus 36I radical 3 over 32. I'm not done yet. Hang with me. You'll love me. Just give me a minute. Let me get there. Divide by what? They all divide by 4. Right? All three numbers, don't listen to Dylan, they all divide by 4. So negative 9 plus or minus 9I radical 3 all over 8. I divided them all by 4. Now, I told you if there's ever a shortcut, I'll show you, right? There's a shortcut. And you're like, thank God, right? That thing is ugly and huge and gross. That's not even graphing. It's easier than that. Take a look. Now, granted, this is the simplified version, but let's come back up to one before I simplified. So I'm looking right here. Let's even look back at this one. Okay? What do you notice about the numbers on both sides of the plus minus? They're the same. What do you notice about what's next to that number with the radical? An I. What's the number under the radical? It's a 3. All right. Now, I'm going to show you the shortcut with a disclaimer. No, it is. The disclaimer is it is only used with the cubed method. Like, it's not every time you use the quadratic formula. All right, so again, disclaimer, this shortcut only works when you're doing the quadratic formula with the cubed method. So any normal problem, use quadratic formula, this does not work on, okay? Only the cubed, only the SOAP pattern. On your green papers I just gave you, you may write this on there, okay? It will be x equals negative b plus or minus bi radical 3 over 2a. So the discriminant, right, that part underneath the radical will always simplify that way. Only on the cubed ones. No. Right. So literally on this problem, I went from here to here right away. I still would have had to simplify all three numbers, but I went from here to here without all of that. A lot faster. Okay, so this right here, can I use this shortcut all the time on every quadratic formula problem? No, this is only the shortcut for the cubed pattern. That's it. Of course. So let's do the next cubed one, and let's try the pattern. See how we do. Now, granted, do I still have to factor it first? Yeah, I still have to factor it. There is no GCF. So let's set it up. Use SOAP, so same, opposite, always positive. What is the cubed root of 8x cubed? 2x, good. Cubed root of 1, 1. Square, multiply, square. So what is 2x squared? Multiply 2x times 1. And then what is 1 squared? So there it is factored. All right, so we need to solve. So x equals, what about this first one? Negative 1 over 2. Now, typically this would be one I'd have to use quadratic formula. I have a shortcut. I may use my shortcut. because you have to, because I've told you, I've beaten to your head to not factor any further because it won't. Right, you're solving. If I just told you to factor, you would just stop there and be like, I'm done. But if I asked you to solve, the next step, since that doesn't factor, would be quadratic formula, but I know how it's going to break down because of the numbers. Yeah. Mm-hmm. And make it positive. Yep. So it's going to be a positive 2 plus or minus. It'd be BI. I already got the plus minus, so the sign's irrelevant. So it'd be 2I radical 3 over 2 times A, which would make that 8. Heck no, I don't need my calculator. Yeah. And then I do need to try to simplify. All three numbers can be divided by 2. So I get 1 plus or minus I radical 3 over 4. So I still need to actually simplify it. But I didn't have to do the whole b squared minus 4ac, figure out what that is, do a factor tree, find my pairs, pull it out. Like, I didn't have to do all that. Because I know it'll come back down to 2I radical 3. I know it will. And it's just because of how the numbers work in the cube pattern. Yay? See, Chris, aren't you happier that you stuck around and let me teach you the shortcut? I promised you guys, if I know a shortcut, I will teach it to you. Shortcut's nice, right? All right. Are we okay? I'm going to give you at least a little bit of time to get started.